So, for independence, you guys need to understand the definition of it. Sometimes you can just answer based on your knowledge and intuition and what you know about events being independent, okay? And other times you have to prove independence using the formula. So you got to know both. So what does it mean for events to be independent? Two events A and B are independent if the occurrence of one event does not change the probability that the other event will happen. All right, a really good example that we tend to use for independence, let's see. Okay. Independent events. Let's say I'm drawing a card from a deck of cards, and I replace it and put it back in for the second draw. Are those events independent? Yes. Okay. Does my first draw affect my second draw if I replace the card? No. So independent events, sometimes you can think of like replacing the card. When you put it back in the deck and you're drawing, then those are definitely independent events, right? But not independent events. The first draw does affect the second draw if you do not replace, right? Similar to the chocolate problem that we just did, right? Did the first candy that you ate affect the second candy? Yes. Okay. What you got on the first one did affect the second one because your next one was only out of 19. So those were not independent events. So independent events, they don't affect each other. Okay. And your formula for that is the probability of A given B equals the probability of A. So you have your conditional probability formula. Do you guys remember that formula? No? Oh dear. Hopefully you guys have this one down. That's the probability of A and B divided by the probability of B. Okay. So conditional probability is equal to just the probability of the first one and the other way around. Okay. You don't have to prove both. One or the other works. Okay. Lefties down under. All right. Is there I think we're talking about Australia. This is why I just normally teach normal math and not math, anything else. Okay. If there is a relationship, or is there a relationship between gender and handedness? To find out, we use census at school's random data selector to choose a simple random sample of 100 Australian high school students who completed a survey. The two-way table displays data on the gender and dominant hand of each student. Let's see. The problem is, are the events male and left-handed independent? All right, so we're going to justify our answer. Male and left-handed independent. So we'll say probability of, oh wait, we want to know if they're left-handed given that they're male. So let's do it this way. Probability of left-handed given that they are male, is that equal to the probability of just being left-handed? So that's formula for independence. So basically, it doesn't matter if they're male or not. Okay. So using your table, and you can do the shortcut on this one, you guys, for probability of left-handed given that they're male. So the shortcut is to just look right here at the male section. And the probability that they are left-handed is 7 out of 46. Okay. And I'm going to put that number down here, 0.152. So there's our decimal. So 15% chance. And then we've got probability of just being left-handed. So we're going to compare that to just being left-handed. So that means I'm going to look at the total over here. I have 90 who are right-handed, 10 who are left-handed, and 100 total. So the probability of being left-handed is 10 out of 100. We get 0.10. In order to be independent, those have to be exactly equal. All right, exactly equal. So these are not independent events. Okay, what does that mean? So that means that there might be an association between being male and being left-handed. Might be. We're going to learn how close that has to be in the future, but for now you can just say they're not independent. If you get the exact same number, then it doesn't matter if you're male or female or left-handed, and then those would be independent events. Okay? You can do these either way. So the way I just did it was left-handed given that they're male. You can also do it the other way, and you should get the same answer, that they are not independent. Okay? Is there a connection between independent events and association between two variables? So in the previous example, we found that the events male and left-handed were not independent. Does that mean there actually is a relationship between the variable genders in the larger population? Maybe or maybe not. If there is no association between the variables, it would be surprising to choose a random sample of 100 students for which the probability of left-handed given male was exactly equal to probability of left-handed. But these two probabilities should be close to equal if there's no association between the variables. How close is close? You guys will find out in issue chapters. For now, you can just say not independent. All right? So let's do a couple problems. Shuffle a deck of cards and turn over the top card. Put it back in the deck, shuffle again, and turn over the top card. Define events. A, first card is heart. B, second card is a heart. Where's the question? Oh, you have to say dependent or independent. What do you guys think? Okay, why? Because it has replacement, so does the first draw affect the second draw? No. Okay. So independent, good job. Shuffle standard deck of cards. Turn over the top two cards, one at a time. Define events. First card's a heart, second card's a heart. So this time you are drawing two cards. Are we replacing them in between? No, does not say that, right? So what about this one? Independent or not independent? Okay, not independent. Once we know the suit of the first card, the probability of getting a heart on the second card will change, depending on what the first card was. Okay? And we'll try another one of these. The 28 students in Mr. Tabor's AP Stats class completed a brief survey. One of the questions asked whether each student was right or left-handed. The 2A table summarizes the data. Choose a student from the class at random. The events of interest are female and right-handed, so I want you guys to check for independence on this one. You guys try it. So here's our formula. We can do these either way. Or you can do it this way. You gotta find. Okay, how'd you get 18, 24? So was that this guy? Which one are you doing? This one? Okay, and this should be 24. So the probability that you're female given right-handed. So here's all our righties in the female section. So that's 18 out of 24. Okay, and then what'd you get for this one? Okay. They both reduce to what? Is that true? Yeah. 7. Okay, good. 3/4 equals 3/4. All right, good. Okay. And you should have gotten this to work, however, whichever way you did this one. All right. It should be true. And so how would we answer this question? Since we got equal, what does that mean? Okay, it means they are independent. So in this case, we got independent events. And so one does not affect the other. Being female doesn't affect right-handedness. Being right-handed doesn't affect being female in this case. In our other one, it did. We got different answers based on our data. So you do need to, one, understand intuitively what it means, but two, be able to do the formula. Everybody good on this one? Okay, short left.